again. In the last section, we have discussed how to create the standing wave on the string for the wave that reflect back and forth between two boundaries. We did not specify the source of the disturbance of the wave. In practice, we need some source. For example, for the wave on the string, we may need the vibrator to disturb the medium, which here is the string, and create the traveling wave that travel from the source to the boundary and reflect back, and create the standing wave between the tip or the blade of the vibrator and the fixed end. By this, the frequency of the vibrator have to match with the appropriate frequency of the standing wave. At those frequency, we call it the resonance frequency. The resonance frequency is the frequency of the vibrator that will create the standing wave on the string. Okay. Someone may say that in this situation, for the ideal standing wave, the two ends of the string must be the node. Okay, it means that at this fixed end, which is of course the string cannot move here, so it is a node. But what happened here? Because the blade here have to vibrate to disturb the medium and create the wave on the string. So this point is not the node, it's not the real node. But in the real situation, when we create the standing wave, what happened is that the amplitude of the oscillation of the standing wave, especially at the antinode, is much larger than the oscillation at the blade here. So practically, we can approximately assume that this point is the node, because the oscillation here is very small compared to the maximum oscillation in the string. So we can have approximately two fixed ends at the fixed boundary here and at the blade of the vibrator. Also, we can see that since when we have the standing wave here, the oscillation can be the largest. I mean, we can have the large amplitude of the oscillation here at the antinode. And how can the medium oscillate? It is because the blade disturbs the medium. On the language of the energy, it means that the blade transfer the energy to the system. Transfer the energy to the system. And once the system oscillates with the maximum amplitude. It means that when the source, which is the vibrator here, transfer the energy to the system at the resonant frequency, that we have the standing wave, we have the maximum energy transfer to the system. So the standing wave is very important in the sense that if you want to create the vibration on the system with fixed 2n, you must give the appropriate frequency to get the maximum energy transfer to the system. This is important, for example, for the musical instrument, that you need the string to create the sound. So if you give the right position of the disturbance or the right value of the frequency that excites the medium, it will give the maximum vibration and will give the bass sound from that instrument.